Well, hey, Math 8, Mr. Erickson here. We are on to Wednesday, which is 5-6, Lesson 2. We will be looking at histograms. It's another type of graph. This one is it has its own lesson because it's a little bit harder, I think, to understand. So it'll be good for us to kind of walk through just what the notes say here, understand some of maybe the nuances, some of those small details will be important here to understanding histograms. And then on Friday, I won't make a video, but you guys will basically be doing an assignment where you guys will find and look at a graph and actually kind of talk about it and describe what it tells you. So that'll be on Friday. But let's go ahead and look at Wednesday's note page here about histograms. So histograms are similar to bar graphs, but instead of categories, they're equal-sized numeric intervals. Okay, so where a bar graph was like, okay, how many students like ice cream or how many students like potato chips? Here we're talking about a numeric interval. So maybe we're saying how many students scored between a 90 and 100% on the last quiz. And then how many students scored between an 80 and an 89% on the last quiz, so maybe having different intervals, and comparing, all right, well, a lot of people got between a 90 and 100 this time, or not that many people got between a 90 and 100, compared to 80 versus between 80 and 89. So that kind of idea. So once again, the differences here, it uses numeric intervals instead of categories. So it's not just you like ice cream, you like potato chips. It's like, okay, what's the number here? It's going to be some kind of number that's going to be used. And then all the bars touch starting at the vertical axis. So we'll have an example down here. If you notice here, average daily temperature in 50 states, notice that these bars almost kind of run together. Do you see how there's no space in between them? The only reason there's a space here between 30 and 39 is that there was nothing in that category, so we had to make it just completely empty, so it's all the way down at the bottom. Otherwise, you see how all the intervals, all the bars touch each other, but notice they're all numeric intervals, right? 20 to 29, 30 to 39, 40 to 49. That's different than saying ice cream or potato chips or whatever the case may be. All right, it's very useful when you have a large amount of numerical data, and a bar graph would be too large to be meaningful. So that is very true. It gives you an overall picture or trend within the numeric intervals. And then just a big heads up here, before making a histogram, you will have to create those intervals. So as I said, we'll get on to making some of these things later on here in the unit, but you'll have to make those classes, and they do have to be equal sized, right? You can't say, okay, how many people got between a 98 and 100 on the test, and then the next interval is between like an 80 and a 98. Like that one's 18 points where the other one's just 2, right? It's got to be the same size. So if you do intervals of 10, it's 91 to 100, so on and so forth. So that's the kind of idea here. So should you make a histogram? So the questions here to ask would be, do you have a large amount of numerical data that's spread out? If you were to put a bar for each little number, it would just look like chaos, right? You want it to, if you have a large number of data, be easy to split them into groups or intervals there. Would it be meaningful to look at the data in intervals instead of each individual number? That's kind of what I just said. Would it be meaningful to determine if there is a pattern within the numerical data? So once again, would it be kind of something where you might see, oh, wow, there's a lot of students that score between an 80 and a 90 versus maybe a 60 and a 70 on this test or this quiz. All right, so to make a histogram, review your data and determine what intervals would make sense. So once again, they should be equal in size. Once again, equal sized intervals, but they could be by 5s, by 10s, by 20s, by 50s. It just depends. It's almost a matter of preference a little bit. There's not necessarily one right answer, but there's definitely some that will tell you and show you a lot better give you a better graphical and visual display versus maybe some others. So there's some better and worser choices maybe for the size of intervals. Size of intervals depend on how spread out the data is. That's true as well. You should try to shoot for, as I said, it's kind of a little up in the air, but you could try to shoot for between 3 and 6 intervals. If you have more than that, it's kind of too much to look at. And if you have less than that, you don't really see what's going on very well. So it is possible to have an interval with no data in it. Once again, down here, we had the example where there's nothing between 30 and 39. All right, so that's that first part there. So you make a frequency table and determine the number of pieces of data in each interval. So notice here, once again, you'd have your intervals here in this first column, and you'd kind of fill that in below there. You would tally them and say, okay, we had how many? Like here, if you noticed, they've tallied how many. Between 40 and 49, there were 22. They counted them up. Between 50 and 59, there were 17. So they've tallied up how many would fall into each each interval. And then lastly, the frequency. Which is basically that same number. In fact, the tally would be kind of more like your stick marks, where the frequency, of course, is what we're actually ending up interested in here. All right, so you draw the graph, label the axis, title the graph. Make sure you kind of do those fundamentals, right? Label everything. Don't just assume, hey, they'll know what I'm talking about, So make sure you've clearly labeled, especially those intervals, because they could be different sizes, things like that. We want to know what are those intervals. That's an important piece of information to have in front of us. Vertical axis would be then the frequency. So how many pieces of data, were in that interval. And then once again, draw your bars. So the height, first of all, the first bar should touch the vertical axis. So the bottom part, should be, or the first one should touch the vertical axis, means kind of over here, right? That first bar starts all the way at the left, and then all the bars touch then, unless it's something where there's no data in that little part. But otherwise, all the other bars, once again, they come up against each other. All right, so here's an example. I've already kind of looked at it a little bit, but just an example here of average daily temperatures of all the 50 states in the United States. So once again, if you look at this table, there's so many numbers, right? If you tried to make a graph of that, first of all, it would take all afternoon, but it would also look really cluttered, and you wouldn't really be able to tell much from it, probably. Let's really kind of focus in what we want to know. What information do we really want to know? If we don't care about the actual temperature for each state, but are just looking for trends, a histogram would be a good choice. It'd be perfect. First, we sort the temperatures from least to greatest to notice we have an average temperatures that range from 22 to 70 degrees Fahrenheit. So let's kind of use that kind of as our lowest and our highest. Let's make intervals between those two numbers, between about 26 and about 70. So breaking it to non-overlapping intervals, we would start at 20 to 29.9. That would come right up against 30 to 39.9, and then keep going, right? 40 to 49.9, so on and so forth. So we can count how many states daily average temperature falls into each category. Then we can make a histogram. So here be, of course, all the data, but then here's the histogram we ended up making. But what's most important is this little table, right? So here's where we decided on our, we got our intervals here, each about 10. It's about 9.9 or so is the size of each interval there, going from 20 up to 79.9. And then we've counted up how many fall within each one. So if we looked at, for example, Alabama, right, 62.8, we would say, well, that falls between 60 and 69. So that would be one of the 8 states that falls in that category, or in that, that interval. And so that's kind of what we're doing here, right? So you would have to do that, of course, technically for each of the states there, and some things like that. All right, so what can we conclude here in conclusion from a histogram? So it looks like there's only one state that has an average daily temperature in the 20s. I bet you guys can't guess what state that is. No states have an average daily temperature in the 30s. Once again, there was nothing in that category or that interval. There are only a couple of states that have an average daily temperature in the 70s. So there's only a couple that are really, really warm. And then the majority of states have average daily temperatures in the 40s and 50s. So kind of the bulk, right? Most of the 50 states here are falling between 40 and 59.9 as far as their average temperature. And it's kind of interesting. We can look at Indiana here. It looks like Indiana, right around Illinois, is at 51.7 degrees Fahrenheit. So that looks like that puts us kind of in this bar here. Barely into that bar, right? Because we're right over 50. We barely made it into that category. But so it's interesting to think there's at least 23 states that have a lower temperature, than us on average. It's kind of interesting. All right, but what can't we conclude? We don't really know the names of the states for each of the temperature intervals, right? We had to go back to look at Indiana. We had to go back to the original data. Now, typically when you're looking at a histogram, you don't see the original data unless you were the one that created it, of course. So, we wouldn't know where Indiana is unless we had the original data right there in front of us. Otherwise, you can't tell individuals, but you can tell kind of the overall, where most states fall, for example. So, all right, there's the link for the assignment to complete. Once again, you'll be answering a bunch of questions about histograms, kind of applying just all of this knowledge. Once again, if you need help, don't hesitate to reach out to me. I'm here to help you. And otherwise, I hope you guys have a great week.